Hello and welcome. Gravity waves are the latest and deepest secret yet pried out of the cosmic microwaves that were discovered accidentally by Arno Penzias and Robert Wilson, both then at Bell Laboratories. They got the Nobel Prize. Dr. Kovac spent his whole career trying to read the secrets of these waves. He is one of 4 leaders of BICEP, which has operated a series of increasingly sensitive radio telescopes at the South Pole, where the air, thin, cold, and dry, creates ideal observing conditions. The others are Clement Pryke of the University of Minnesota, Jamie Bock of the California Institute of Technology, and Dr. Kuo of Stanford. The South Pole is the closest you can get to space and still be on the ground, Dr. Kovac said. He has been there 23 times, he said, wintering over in 1994. I've been hooked there ever since, he said. In 2002, he was part of a team that discovered that the microwave radiation was polarized, meaning the light waves had a slight preference to vibrate in one direction rather than another. This was a step toward the ultimate goal of detecting the gravitational waves from inflation. Such waves, squeezing space in one direction and stretching it in another as they go by, would twist the direction of polarization of the microwaves, theorists said. As a result, maps of the polarization in the sky should have little arrows going in spirals. Detecting those spirals required measuring infinitesimally small differences in the temperatures of the microwaves. The group's telescope, BICEP-2, is basically a giant superconducting thermometer. We had no expectations for what we would see, Dr. Kovac said. The earlier Planck study had concluded that a parameter R, which is a measure of the swirliness of the polarization, could not be higher than 0.11, which would have knocked many popular versions of inflation, but it was not a direct measurement as the BICEP team was attempting. The BICEP measurement of R clocked in at nearly twice that, 0.20, putting the most favored models back into contention. The strength of the signals surprised the researchers, and they spent a year burning up time on a Harvard supercomputer, making sure they had things right, and worrying that competitors might beat them to the breakthrough. The data traced the onset of inflation to a time in cosmic history that physicists like Dr. Guth, staying up late in his Palo Alto house years ago, suspected was a special breakpoint in the evolution of the universe. Physicists recognized 4 forces at work in the world today: gravity, electromagnetism, and the strong and weak nuclear forces. But they have long suspected that those are simply different manifestations of a single unified force that ruled the universe in its earliest, hottest moments. As the universe cooled, according to this theory, there was a fall from grace, not unlike some old folk mythology of gods or brothers falling out with each other. The laws of physics evolved, with one force after another freezing out or splitting away. That was where Dr. Guth came in. Under some circumstances, a glass of water can stay liquid as the temperature falls below 32 degrees until it is disturbed, at which point it will rapidly freeze, releasing latent heat in the process. Similarly, the universe could supercool and stay in a unified state too long. In that case, space itself would become temporarily imbued with a mysterious kind of latent heat or energy. Inserted into Einstein's equations, the latent energy would act as a kind of anti-gravity, and the universe would blow itself up. Since it was space itself supplying the repulsive force, the more space was created, the harder it pushed apart. In a runaway explosion, what would become our observable universe mushroomed in size at least a trillion fold from a submicroscopic speck of primordial energy to the size of a grapefruit in less than a cosmic eye blink. Almost as quickly, this energy would decay into ordinary particles and radiation that were already in sync, despite how far apart they wound up, because they had all sprung from such a tiny primordial point, as if the galaxies had gotten together in the locker room to make a plan before going out. All of normal cosmic history was still ahead, resulting in today's observable universe, a patch of sky and stars 14 billion light years across. It's often said that there's no such thing as a free lunch, Dr. Guth likes to say, but the universe might be the ultimate free lunch. Make that free lunches. Most of the 100 or so models that have been spawned by Dr. Guth's original vision suggest that inflation, once started, is eternal. Even as our own universe settled down to a comfortable homing expansion with atoms, stars, and planets, the rest of the cosmos will continue blowing up, spinning off other bubbles here and there endlessly, a concept known as the multiverse. The BICEP data does not reveal what this magical sounding inflating energy is. Anti-gravity might sound crazy, but it was Einstein who first raised the possibility of its permeating space in the form of a fudge factor called the cosmological constant, which he later abandoned as a blunder. It was revived with the discovery years ago that something called dark energy is giving a boost to the expansion of the universe, however, far more gently. So the future of the cosmos is perhaps bright and fruitful. But do not bother asking about going any deeper into the past. As Dr. Guth will be the first to say, we might never know scientifically what happened before inflation at the very beginning, because inflation erases everything that came before it. All the chaos and randomness of the primordial moment are swept away forever out of our view. Please subscribe to this video and share it with your family, friends, and others who need it. God bless you for now.